Thank you so much. And yes, I'm not going to do a lot of evangelizing today, but people who know me a little bit sort of know 3 fun facts about me. And the one is I tend to explain everything with car analogies. I tend to travel with little mice, and I like to dive deep and dabble in sort of topics. And today I'm going to do a little bit of all 3. So I'm writing a book. I'm working with platforms. I'm writing a book on platform strategy and working for a cloud vendor. We're sort of building a platform, you could say, and almost every other client we're going to is building some form of in-house developer platform. And when we speak to them, we usually get a comment like this, like we make this platform because we're abstracting away things, and because that, the cognitive load goes down for the teams, and because of that, we are like, faster, better, cheaper, everything will go well. And I say this could be the case, but for my flavor, there's a bit many buzzwords in there. And sort of Dilbert has fallen a little bit out of favor, but I think the buzzword bingo is still very valid. I would call bingo on this. And I'm not going to go so much into the cognitive load. It's also a super interesting topic, but I'm going to focus on sort of the abstractions. Yeah, and as Richard said, I'm no newcomer to YOW. So actually in 2017, this was in Brisbane over in the Red Room. So apparently I did better that year. They gave me the big room. I talked a little bit about what it makes an architect. Like, I don't believe that's something you have on a business card or a title, but I believe it's sort of a way of thinking, a way of working. And I snuck the word abstractions in there also. And here's one of the mice I mentioned. So apparently I had some idea that this abstraction thing is something important that we need, and it turns out it has actually become more important than ever. So let me explain first why abstraction isn't anything new for architects, right? Like, this is out of the talk from back then, so a tiny bit of recycling or refresher, let's say. So one thing we said as architects, we use models, right? We like to draw pictures and diagrams, and they are inherently models, right? And models are never reality. Like, California is not painted green and Nevada is not painted yellow. Last time I checked, when I went for the hike, I in vain looked for all the topographical lines and couldn't really find those, right? These things are not reality, right? They're models. They're meant to be abstractions. So they omit a lot of detail, and sometimes they add other things which actually don't exist in reality. Coincidentally, there's also very old books called Data and Reality. The opening statement is pretty much like, highways are not painted red and the rivers don't have the dotted county lines down at the bottom. So that is all about data modeling and abstraction. So this is something we use quite a lot. I used this slide back then to show that there is not one best model. There isn't like the perfect abstraction, the perfect model, but it depends on what question you're trying to answer. So the question of like, oh, what is the best model here? These are obviously 4 models of a system we know very well. That system is called planet Earth, right? Which one of this is the best map? It's a catch question, right? It depends on what you're trying to do. If you're trying to build outside the flood zone or go on a hike or build a ski resort, right, a topographical map is very useful, right? If you try to understand the US elections, my old joke is, no, that doesn't help really either. But in theory, the political map should give you some hint on how that works. Then if you're going on a drive, the highway map, and then some of us are in the business of building distribution and fulfillment centers, so population density maps are actually very helpful. So short reminder there, right? As architects, we use models. Models don't stand on their own. Models are there to help you make better decisions. So if you pick a model, you should have a question in mind. You should have a problem that you need to solve or a question that you need to answer, and that's what we're using these models for. And you can see these models have very different kind of abstractions. They omit very, very different things. And this relates well to one of my things. Sometimes I give a talk about sort of the ways architects think, and one of the ways I show is as architects we tend to zoom in and zoom out, right? Just like the maps, they zoom out, but they don't zoom out. They're not a photo of the Earth sort of made smaller. When we zoom in and zoom out, we see different things. And that's, again, key aspect of this abstraction. Our systems look different at different levels of zooming out. And I will have some good examples of that later. So much for abstraction, obviously a key part of our repertoire. So how much is there left to say about it? Well, I hinted in the beginning that the platform story has quite a bit to do with abstractions, and that is a hot topic, right? We're building platforms, and we're building them for good reasons. A common word, another buzzword that we use is shift left, right? We shifted everything left because all these separations between the teams and the development processes, right, that's kind of cumbersome. So having a different dev and a different ops team, that doesn't work so well. So why don't we make the developers also do the operations? You build it, you run it. We actually do this. Well, how about security, right? It's also cumbersome if that's done in the end. Sure, the developers also concern themselves with security. And how about business requirements, right? With the business analyst, that never really works so well, like all this translation, right? Why doesn't the development team be closer to the business domain? And so on and so forth. And I call this no longer shifting left, I call it piling left, right? Because in the end, so the development teams, they do like everything, right? So they need a little bit of help. So the buzzwordy thing at the beginning is actually well intended. The catch is that we don't always live up to our good intentions. So we want to reduce the cognitive load because we piled so many more things onto the development teams. So the abstractions and the platforms can help there. And part of that is, besides the piling everything left, I work in the cloud. The cloud is amazing, but everything in the cloud is distributed, has a fine-grained security model, it costs money, right? So it is also amazingly complex, let's be honest, right? It can do amazing things, but building and deploying the monolith and running it under your desk was a little bit easier than making all these asynchronous distributed kind of thingies. We do them for good reasons, right? But we need to keep this in mind. So we have a universal weapon in this fight against complexity, and that is called a layer of indirection. I think Andrew Koenig was the one who coined the term, the quote by David Wheeler, which is, we can solve every problem by one additional layer, by one additional level. There's a footnote, and that is, except the problems of having too many layers, right? But other than that, we've done pretty well. So the question is, does that also work here? Can we abstract things away? Can we actually reduce the cognitive load? So I hinted at the car analogies. So when I talk about platforms and think about platforms, that is not a new idea. So a bit of a fallacy we have as IT people is we always believe we invented everything, because before us obviously came the Stone Age, right? So we start sort of at zero and everything we invent, and not quite 100% true. So the platform concept itself and this hiding of complexity, car manufacturers have been doing since the 70s very successfully. Volkswagen was one of the initial ones. I was very happy in Las Vegas. I met one of the guys who makes these Volkswagen car platforms. Was it called MQB or something? So it was quite amazing to me to find somebody who makes like mechanical, physical product platforms. And the idea is relatively similar, right? Cars have a lot of complexity underneath. In my corporate speak, that would be called undifferentiated heavy lifting, right? So in the cars, that is the engine, transmission, anti-lock brakes, emission controls, all that kind of stuff that is really expensive to design. But when somebody buys the car, they don't really look at all these. They want it to look nice, feel nice, be fuel efficient, right? So the idea is, can't I reuse all the stuff underneath and put something else on top? And I can make many models of a car without having to sort of rebuild all the stuff underneath, and hopefully also reduce the complexity of this whole thing along the way. So the idea is sound, and basically every car manufacturer these days does it like that. And this is the same principle that's behind the cloud, right? You don't want to be in the business of building globally distributed relational databases, right? We do things like that. You don't want to build serverless runtimes. All the cloud providers do that. So that's the chassis, right? The platform, and then you build your applications on top, and you can choose, what kind of leather seats you put, and the color and the shape of the body and all the things that the customers really care about. So good idea, but as I said, we don't always live up to the expectations of our ideas. And the biggest trap that I find is that when we say abstraction, we often actually do composition. And composition isn't a really good abstraction. I will give some examples. So I joked about this publicly, and I think this is the end of my car analogies, don't worry. If the engineers had named the car, it would be called I'm going to read this off, the piston, crankshaft, gear, wheel, assembly, singleton, factory, probably. That's how we think, right? And luckily the engineers did not name the car, right? It was named the automobile, something that can move on its own. So naming something by the pieces that it's made out of is not a useful abstraction. And now most of you are saying like, oh, tell me something new. Like, obviously not, but it's very easy to see how this happens. If this was so obvious, I wouldn't have much of a talk to give because all my bad example would have disappeared. So this smart advice is a little bit like brush your teeth every morning, exercise, eat healthy. We seem to all know this, but then when reality hits, we get a little bit weak and then we end up with things like that. So one easy test whether an abstraction is actually a candidate, let's say at least, for something that abstracts is, it needs to bring a different vocabulary. If the abstraction uses the same words of the stuff underneath, well, by definition, it's not really abstracting something, because if I don't know what a piston and a crankshaft is, like, that isn't a very useful name. It's not helping me. So easy test is that you have something that shields you from the underlying complexity and has a different vocabulary. Oh, and then I had hinted this is the last, previous one was the last car example, so maybe this one is the last car analogy. So here we have a useful abstraction. You push this pedal and your car goes faster. And we often call this gas pedal. And we failed yet again, right? Because that is not a useful abstraction. You take the electric car, they don't even have gas. Well, sometimes they have gas in the batteries, but that's very bad. So normally they shouldn't have gas, right? So this abstraction, like gas pedal, again, is a horrible name for this thing. This is the accelerator. It makes the car go faster. And I'm not trying to be funny with the words here. That is fundamental, right? In an electric car, accelerator makes sense. Gas pedal no longer makes sense. So naming things from the bottom up is so tempting, right? Because the first person who probably put the pedal in had the wire to the carburetor and the throttle. It's like, oh yeah, then the more I push the pedal, the more gas goes in, right? I call this the gas pedal. It's so obvious, but in the end, it doesn't help the users. It doesn't provide the abstraction because it uses the vocabulary from underneath, and that's why accelerator is a much better word. So I'm getting off the cars, and I'm holding up to mirror to ourselves, right? I work at AWS, and we have solution libraries. And every once in a while, our technical writers get a little bit creative, and they write things like define high-level abstractions. And these high-level abstractions are event bridge, lambda, SNS, SQS, step functions, DynamoDB, Kinesis, Firehose. Fantastic. Very high-level abstractions. No, they're not. These are the components. This is piston, crankshaft, gear assembly, and these are great services, right? We build them. They all work very fine, but there is, again, absolutely no abstraction in here. If you don't know what SNS, SQS, Kinesis, Firehose is, like, this thing isn't going to help you go forward. So we're a little bit guilty of that, and because it's unfair to sort of dish out at my employer, I'm going to dish out at myself also. So this is from the Enterprise Integration Patterns book, just celebrated its 20th anniversary, just like DDD. Eric Evans' DDD came out like just a couple of weeks before us, and we both really launched at OOPSLA 2003. So here we have a pattern, and the pattern is called scatter gather. Kind of cute name, like scatter something and collect it back, works really well. If you look at the URLs, it wasn't always called scatter gather. It was called broadcast aggregate. Well, that's the piston and the crankshaft and the gears and the wheels, because we named it after the pieces. There's another pattern, it's called claim check, like a message comes in and you store a lot of the payload to be picked up later. Claim check is a really nice name for this, right? It's like checking your coat when you go somewhere and you get that claim check and you pick it up later, or your luggage at the airline. That was called store in database originally. So we fell exactly in the same trap. It is so easy. Oh, what does this thing do? Well, it stores stuff in the database. Isn't that a great name? No, that is actually not a great name, because you're not abstracting. You're just like sort of, piston crankshaft kind of thing. So happens to us, so I'm very understanding. So, we can be sort of all in this together. Perfect examples where if you build the stuff at the bottom, it's so easy and so natural to want to name your things by what you have put together from, but you fail to make a meaningful abstraction. And yes, I'm part of the same club. I made the same mistake many times over. So let's not be all depressed, right? Let's look at some really good abstractions. This is a really nice abstraction. Unfortunately, the round plugs won't work here, so there's a little bit of variation here. It's probably another talk. It's the challenges of standardization and harmonization. But overall, this is a pretty amazing abstraction, right? I plug something in the socket, and underneath is a giant machinery. And yes, in this case, we also changed the sources, or hopefully from coal to gas to renewables, water, solar, right? And my little socket actually never changes. So these abstractions are really good, and we can learn a lot about why they're good, right? This is not called coal, oven, boiler, turbine, generator, wire, transformer thing. It's called the power socket, right? It's the socket where I get power. So the interface is separated from the implementation. It's highly standardized. There's a nice layering here behind it, and that is good. One thing to be careful though about, and we come back to this, is these abstractions still leak. So this is a fantastic abstraction, but if the power goes out, if the power station fails, and you don't have sort of another one to kick in, your abstraction also fails, right? The socket will also be out of power. So you cannot always abstract everything, but I find that to be okay, right? You can abstract as much as you can, and then you can be honest, like a big power outage. I live in Southeast Asia. We tend to have a lot of those. The transformer at the corner always blows, right? And my nice little abstraction, kind of goes away. One more layer of indirection actually solves that problem. Of course, I have a UPS, right? As we said in your fundamental theorem, one more layer of indirection, I plug a uninterruptible power supply into my little plug, and then actually I solved that problem. So layering sometimes does work. Well, let's go back to IT, right? Enough cars and power stations. Here's a very nice abstraction, right? Most people I know who read from files or code against the network, unless you do something high-frequency trading or very low latency kind of things, most likely you will make that a stream, well knowing that file storage is in sectors on disks. They're physically aligned. They have a certain size. The network has packets and packet routing, and they go out of order, and they get lost, and all these kind of things. But fundamentally, having a stream abstraction works very, very well. Now, the funny part, so this is all the stuff underneath that basically, in most cases, you don't need to worry about. Now, the funny thing about this is that these abstractions tend to come along quite rarely, actually, right? Like, I don't know, when did people invent the stream? Maybe like the 70s or something? Would say like half a century or so. So these like really good abstractions, they come like every decade or so. So that gives us a hint that they're probably actually not so easy to make. So let's summarize and come back sort of the abstraction versus composition, right? So composition is useful. So the recipes I showed on the car is obviously very useful, right? So these solution constructs I showed, this S lambda to SNS to kinesis stream, they're very useful. They save you work, right? They allow you to do multiple things at once, but they do not qualify in my book as an abstraction because they're only useful if you know all the pieces underneath, and that's kind of per definition undoes the idea of abstraction. Counterexample, like the stream interface doesn't talk about packets or disk sectors, so that is a valid abstraction that actually holds because you have a different language that you speak, and that takes a lot of the details away. Now, abstractions are great. Hopefully I convinced everybody of that, but there is too much of a good thing is usually a bad thing, and the same is true with abstractions. If you try to abstract too much, you end up building illusions, and I will explain what that is. First, coming back to the physical limitations, right? I said the power station, if the power goes out, basically abstraction cannot overcome that. Joel Spolsky called this the law of leaky abstractions. He said all abstractions are leaky, and I would say yes, they are, but I already hinted, I say in many cases that is okay, or it is not a reason not to make abstractions. And the example he cites are exactly out of the network, like physical elements, congestion, network congestion, connectivity drops, right? Logical abstraction layers cannot abstract away physical properties. right? And I talk about this a lot, actually. I work for a cloud provider. There's a lot of people building abstraction layers over clouds, and I always say, logically, this might work. But when it comes to latency, pricing models, quotas, like all the physical kind of stuff, where is your region, is the service available in this region, all that physical stuff you cannot abstract away with a logical layer. By the way, this was a very bad leaky abstraction. There's actually water running in my power socket. So my beautiful abstraction there is literally leaking, and that was not a good thing. So yeah, abstractions are leaky, but that's as I said, you need to be aware of that, but in many cases it is okay. Yeah, and here my point, right? You abstract away logical elements. The physical elements, we'll come back to that. They can't magically made to go away, but I think you can also find ways to model them, and I'll talk about this later. So not all is lost, just as a going-in position, right? Let's say you make a logical abstraction over 2 different cloud providers. Logically, that's likely going to work well. It doesn't solve anything like quota limits, pricing models, latency, all these other kind of things. So we need to be a bit more differentiated when we do these abstractions. Well, the best case where we made an illusion because we tried to hide all the physical aspects and pretend they don't exist, that has a name. That is called RPC. We said, oh, isn't a remote method call just like a local method call, right? You call this thing, it comes back with the answer. It's like, isn't this the perfect abstraction? And of course is not, because all the things are distributed systems. You pretend they don't go, you pretend they go away. So some people might say this is a lie. I'm a little bit more polite. I say this is an illusion, right? It pretends to be something that it cannot be, because it pretends to have no latency. It pretends to have no partial failure, right? It pretends to have no retries. It pretends to have no congestions, right? Remember, the streaming is sort of an asynchronous kind of thing. You're fetching from the stream, and maybe something comes, maybe not, right? You're prepared for many of these things. RPC pretends that this is just like a local call where you have shared memory and a call stack and exceptions, and you don't have that in the distributed world. So this is not a leaky abstraction per se, but this is no longer a useful abstraction. This is an illusion. So what we learn here is that this abstraction thing is delicate, right? We easily fall into not abstracting much at all. That's the piston crankshaft, SNS lambda kinesis stream thing, right? But then there's the opposite danger of abstracting too much, and then we're misleading the users, and that is actually also no good. So how do we make this right? Well, there's always a clever piece of advice. In the short form, it depends, but we have a little bit more explanation, and that is when you omit essential details, then you end up with an illusion. Now, the footnote to this is, well, what is essential and what is not? And I said, well, this is, ChatGPT will probably not help you. You should use your human intelligence. This is architect work. This is judgment. Right? Maybe in some cases, I worked at Google many years ago, we actually did a lot with RPC, but that's because we controlled the whole stack. We had our network. We could make things low latency. We had many, many other things that made that possible. So for us, that actually worked. But for most other people, it does not. So it's a judgment call. It depends on the context. It depends on what you're after. It depends on what you want to emphasize. It is a judgment call. There's no easy recipe here, and I will give some more examples. So that's the difference between abstraction and illusion, right? The abstraction lives from removing things, removing the noise to amplify what is important, and we saw that on the maps, right, in the beginning. It removed many things and it added some others, and that way we can make a better decision about our ski resort or building the house outside the flood zone. The illusion comes when we remove important or essential details that then mislead the user. And I said essential or important are these weasel words here, and that really means it's architect work to decide what goes in and what goes out. Now, as you can imagine, right, I work at a cloud provider, so we face this problem all the time. What should we hide? What should we expose? right? And we argue over this all the time. There isn't like an easy sort of oracle we can go to and say like, oh, what should be sort of the right level? It's not. We have a lot of different opinions, and there's a lot of arguments going back and forth, highlighting that this is actually pretty nuanced, and perhaps also a little bit of personal style and opinion maybe in there. And I'll reveal which camp I am in. So what we learn is that less is not always more, right? Sometimes less is actually less. Too much of a good thing is a bad thing. If I abstract away too much, I build illusions. So let's make sure somewhere we stay in this just right sort of Goldilocks zone of, I hide enough details, but I'm not hiding too much. Great architecture advice. As a consultant, you can make infinite billing out of this, right? Because, of course, it says everything and nothing. Yeah, you just need to get it just right. When the customers ask, well, how do I do this? You say, here's the statement of work, right? So perfect. Luckily, I'm no longer a consultant, so I can always joke about this. But I will give some, don't worry, I will give some very, very concrete example. My way of highlighting this, sometimes when you show people these abstract things, right, it's not as easy to have the argument. So always like to take it to the extreme and say, oh, if that was the right path, well, why isn't my system sort of one method and it's called do the right thing? Wouldn't that be the most fantastic abstraction? You just need to carefully consider the Boolean parameter, and then off you go. And then people are like, oh, that's stupid. I'm like, well, yeah, thank you for making my point, right? So sometimes it helps to sort of take it ad absurdum, to say people, no, that is not the goal. The goal is to be somewhere below that and have some granularity underneath, have some vocabulary underneath, right, where you give people flexibility, but at the same time, you're not making illusions. So coming back to platforms, right, because I said a lot of this thinking is because I'm writing this platform strategy book, and see a lot of people building platforms. Again, here's a little bit of a failure mode. So I have a bad example and a good example. So a lot of people, what they do, and I work on serverless. So DynamoDB is always my favorite example. Use whatever you prefer. What people do when they make a platform, they say, ooh, the cloud service, like XYZ, has too many settings. A, that is a high cognitive load, and B, that might be a security risk, right? Because you might be in a region that we don't like, and maybe you don't have backup or replication enabled, or maybe you pick a very expensive option, right? So there'll be dragons, basically. And they said, oh, why don't we provide sane defaults, right? And make this easier for you, right? And they say, you get a better database. You get like our version of this database. And you can sort of hint from my tone is, this is slippery slope, because you're not giving them a better database, you're giving them sort of like a 75% database. And this never goes well when you roll out a platform. Right? It's like, oh, look, I made this so much easier for you. You have like the better DynamoDB, and people say, no, this is like 80% DynamoDB. Why don't I use 100% because it costs the same? Well, actually it costs less because I don't need all the stuff that you built on top, right? And I get all the features, so where is my benefit here? The metaphor I'd like to use about this is if somebody is trying to solve a jigsaw puzzle, and they have 1,000 pieces, right? Not easy, they're struggling putting all this puzzle. And you go and you take 100 pieces away. You did not make their life easier. You actually made their life much harder, because they don't even know if the piece is there or not. But that's what the platforms do. They take some pieces out and say, oh, look, now we have only 900 pieces. Isn't that a lot better? No, it's totally not. Now, the good news is, and I said I don't want to make this a depressing talk, like the good news is I've also seen some very nice examples. And the key point is the nice examples aren't particularly complex. They're relatively simple, but a change in mindset and a change in wording makes all the difference. And you see sort of some of the words in the title. So this is an insurance company. They keep audit logs and ledgers, right? When they make an update to any kind of data set, they need to show exactly what they did because regulated industry, yada, yada, well-known kind of thing. So they made a concept called a ledgered database. And underneath it's not all that different than the thing on the left, right? They use, they're in AWS, right? So they use DynamoDB, they use pipes to sort of get a change log. It's called DynamoDB streams. It gets read by pipes, and it writes into another database. So not that different. The key difference is what they call this. They have a better language for this. This is a ledgered database. And that is not Amazon or Azure vocabulary, right? That is business vocabulary. That is business technical vocabulary. Right? Any insurance company, any bank will know, yeah, this makes total sense. I have you can call it an audited database or ledger database, right? Any financial person will immediately say, yeah, I totally get what this thing will do. It keeps a change log of everything that I did. And those are the small nuances that make all the difference. So I made it sound like these abstractions are really hard to make. The funny thing is, they're hard to think about it. You need to sort of spin the gears a little bit more. But once you have them, it is actually fairly obvious. Yeah, this is like a ledgered database. I have other example, like Mike Roberts, good friend of ours, he made a construct and he called this hosted website. Underneath is Route 53 and S3 and all the other kind of things, but it's not the piston crankshaft. He called this hosted website, and that is also a meaningful abstraction. So the key thing here is, I mentioned earlier, DDD, right, Domain-Driven Design, Eric Evans' book, that actually plays an enormous role here. So what I find is that, maybe this is my strong opinion, that obviously, nobody needs to be convinced how important domain-driven design is, right? Because that's how we can have the ubiquitous language. We understand the complexity of what we are building. But most of the time when we think DDD, we think about the business domain, right? Oh, what does my bank do? What the customer? We think about accounts and money and loans and interest rates and all. Like, that's where most of our focus is. And when I said our world is amazing, but also amazingly complex, I find that this technical domain modeling becomes quite important, right? Like sort of one layer down from the business. So this is exactly between the database, between the technical layer and the business sort of regulatory requirement. And I find there's actually quite a big layer there that we usually very cavalier about, that we're very sort of fuzzy and relaxed, because it's like, oh, do you use what you need as a database? Oh, you need another database, fine. You need to put stuff from here to there, fine, whatever, I can do that. But we never go back and say, what is that domain? What is that vocabulary? What is the language to express that? And I feel that is very much connected to the notion of finding abstractions, because I said the abstractions should bring a new vocabulary. Well, where does that vocabulary come from, right? And in the case of platforms, that comes from this technical domain that we should be much more precise about how we describe that. Now, the nice thing is, if you do this reasonably well, you get a magical thing like this. And actually, I should probably show two diagrams. So in the old world, every IT strategy, every architecture strategy document always has a pyramid in it. Actually, somebody told me it's not a pyramid, it's a triangle. It's kind of true. I don't know why we call the 2D triangle a pyramid, because apparently it sounds better. But we always have like a triangle. Right? We're saying, oh, a common functionality, across the whole enterprise, then functionality for each geographic market, and on the top, you just configure, and then you're done and ready to go. And that sounded good on paper, but never worked. And it didn't work because it assumed that the people who make the base layers can anticipate all needs from the upper layers, right? You anticipated everything. It's like to do the right thing, right? It's just like pass true or false, right? And now you're good to go. Maybe it's an enum, right? So you're like, do the right thing, enum across my business divisions, and then off to go. Now that obviously does not work. Sounds so appealing, right? Because the economics of this thing would be fantastic, but the fantastic economics of something that doesn't work are not great, right? They're actually very bad because it cannot function. So when I started thinking about how is a platform different than the other stuff, and how do we deal differently with abstractions, is that having this middle layer, having this vocabulary, shields a lot of the complexity underneath. So it's really useful to get you to think more easily about it, reduce the cognitive load, but it doesn't assume that on the top is just a tiny tip. On top, you can have a lot of flexibility, right? On the cloud, you can build whatever you want. At the same time, you don't need to think about, globally distributed transactions. So we took a lot of complexity out without constraining you. And that is really magical, and that has a lot to do with finding the right abstractions. The subtitle of my book is Innovation Through Harmonization, right? We always think if you harmonize a lot, innovation goes down because you can't do anything. No, that is not true. You can harmonize a lot, and the cloud shows that, and still be an innovation booster. And I think that has a lot to do with what that language in the middle look like. If you abstract too much, then it's do the right thing, then you harmonized a lot, but you have no innovation on top. And if it's the piston crankshaft gear assembly, yeah, you have a lot of flexibility, but you didn't abstract much out of it. So this is the picture you really want to aim for. So now it's time to make this a bit more concrete, and I'll use my own domain. I work on serverless, distributed systems, sort of step functions, event bridge, lambda kind of things. And I said we have a lot of arguments about it, so I'm not here to preach, but I'm here to sort of relay sort of how the arguments go. So first thing, as an architect, one of the key maneuvers I always find useful is consider things to not be one dimension. Yeah, people argue about, oh, is it left or right? Is it left or right? And I have some nice pictures where I say, no, this is actually a 3D universe. You don't have to go left or right. You can actually go the other direction. So same is true for abstractions. There are multiple dimensions to most things that you abstract. And I hinted at this earlier, right? Functional abstraction versus runtime abstraction, like logical versus physical stuff. Like in the cloud, all the systems are distributed, so they have a lot of physical aspects, right? They have latency, they have cost also, right? So those don't go away, so you can think about, how do I deal with these abstractions in two different dimensions? And that is a very valuable thought, breaking this problem down into multiple subdimensions and then thinking about what kind of abstraction does each dimension afford. Now, I can say this now because, or maybe I take this sort of as self-celebratory evidence that I became smarter than I was 20 years ago, because 20 years ago I didn't know that. Because 20 years ago we made this pattern language, and quite honestly, this is almost all data flow. This is almost all functional. There's very little physical runtime kind of things. On one hand, the cloud wasn't anywhere near. B, you could make the argument that asynchronous messaging is somewhat immune to many physical things, right? It deals well with latency. It doesn't have the RPC. So there's many weasel ways out of it where we could justify it, but the short answer is we never talked about control flow here. This is all data flow, right? These are all the integration patterns. How does the message get routed? How is it transformed? How does it get split? How does it get aggregated? Well, that is all data. This is what does the message look like and what happens to the message. And we never talk about control flow much. There's a few tiny things like idempotent receivers and things where you can say, they're kind of touching the borderline, because the reason I need idempotency is maybe because I have at least once delivery, right? So you can start to see a few physical things getting in, but by and large, this pattern language ignores that. So luckily, over 20 years, we learned, right? So where's my control flow here? And actually, I have to admit, this wasn't even my idea. Super genius buddy of mine, Ivan Giverts, like 15 years ago almost, said, why don't we extend the notation? Why don't we put little noses on this? And those noses indicate the control flow. So a little outward nose, that means like an active thread, like I have something running, pulling from somewhere else or pushing somewhere else. And then the little nook is the opposite. It's basically sitting there doing nothing until something either pulls or pushes, right? And you can see like what he called pool, that's what we commonly call a queue. Just gave a whole talk and reInvent about control flows and flow control, right? The magic thing of queues is that you have inverse control flow on both sides, right? One side pushes in, so control flow goes this way, and the other side pulls out, so control flow goes that way. So queues have the magical property of inverting the control flow, and you can see this with the pool icon, right? It's two little nooks, so the two noses will go from both sides. So now we have a nice abstraction. So we exposed more detail, right? This is something that wasn't there before. So you could say we increased the cognitive load, right? Because drawing the rectangular box is easier than drawing the box with the noses and the nooks. But if you realize that in a distributed cloud system this matters, then this is probably a useful abstraction. It's another dimension. If you're doing something very local, if this sort of Apache Camel and this is mostly memory, you do not need the noses very much. But in a serverless environment, they matter. So again, it's the context, right? Sometimes this is in the essential properties, right? For me, these are essential. Like in memory Java, they're probably not essential. So let me give you a real example. I always joke that I have sort of never before seen content because I just made these slides 10 minutes ago. So I hope they look okay. So guaranteed new content. I'm saying, here's AWS, right? And it's not a lecture on AWS. What I'm trying to do is have a database, and whenever there's a change in the database, I want to trigger some workflow, like plausible enough, right? So the way I think about it is like the top. Right? I have the database changes go over there, and then over there does some workflow, whatever it needs to do. Right? That's how I think about my architecture. But in reality, the implementation looks very different. Even the very high-level implementation diagram looks different because DynamoDB publishes those changes into a DynamoDB stream. A stream is not an active component. It's a passive component. You need to poll. You need to pull from that. It doesn't push anything anywhere. So the little nose would be going, I need to be careful with my hands here. So I think the little nose would be going this direction because something needs to pull from it. And we have a tool, that's EventBridge Pipes. I work on this, I like it a lot, right? But you need to realize that the implementation architecture is actually quite different from the way you think about it. And if you don't know if a stream is push or pull, right, you will not be happy there, right? You will not be able to find the right tool. How do I know that I need to use pipes for this? Well, I can read 20 pages of documentation, or I can just understand, yeah, this is a pulling source. The thing that pulls is pipes, so if I understand control flow, then this is very easy. If it was up to me, right, I would put little noses on these icons. Marketing would kill me, of course, right? But for me, it would be, I would put little noses and nooks, and then when you put it on, you're like, obviously, like, this thing has a little nook, so the other one needs to have a nose, and the only thing with a nose is pipes, and you would be all done. So that's the power of exposing some of these details and making it easy to do. So that summarizes in a way a little bit. So there's two ways of getting at it, right? The one is hiding the complexity. The other one is exposing some of the complexity, but making it easy to deal with the complexity. I'm in that camp very much because I've seen so many bad illusions where people try to hide things. I said, no, let's not hide this, but let's make it easy to deal with. So I'm in the camp of, distributed asynchronous messaging, cloud serverless stuff, that the list of essential stuff is actually relatively long. Delivery semantics, is this at least one? Are you pushing, are you pulling? Do you have time to lift settings in your queue? Do you have back pressure? Classic distributed system stuff. And now you're saying, gosh, right, and I thought the cloud thing wasn't so difficult, and you're giving me all this stuff that I need to now deal with. But I think that is exactly the magic of the abstractions. I can expose this to you and give you a vocabulary for this, but I can make a good domain model that actually makes it easier for you to work with this. So I'm not lying to you, I'm not giving you an illusion, but I'm giving you the tools to do this better. Now, this is stuff I'm actually working on, so just like briefly and a little bit sort of anonymized, one of the challenges that I need to overcome is that most cloud automation tools model the cloud stuff as a resource hierarchy. There's an availability zone, and there's a VPC inside, and an autoscaler group, and inside is a EC2 instance. It's like the Matryoshka dolls, like the Russian dolls, right? It's a nesting meta model. And in the old days, for VPCs and virtual machines, that probably worked really well. For all the stuff we just talked about, that doesn't help us at all. Like, no picture we drew looks like the left, right? All the pictures we drew looks like the right. What goes from where to where? What is my data flow? What is my control flow? So if you want to make this easier to develop against, you need to flip basically the composition model. We're not caring about the nesting as much. We're caring much more about data and control flow. And as I said, I sort of anonymized this a little bit here, sort of in bad pseudocode, because this is work in progress, but that is exactly what I'm doing. So rather than saying I need an instance of this EventBridge pipes where I need to know that this pulls from here and it pushes over there, I can have a programming abstraction that's a pipeline. And funnily, this is going back sort of the era, almost the era of streams. This is like the pipes and filters pattern, right? It's from the 90s probably, right? At least it's in Mary Shaw and Dave Garland's book on software architecture, and that is 95, I think, right, or somewhere there, early 90s. So this goes also back 30 years. But yeah, here we can have a programming model that adequately reflects what I'm trying to do. And you can make now the argument saying, oh, oh, but where is the control flow here? This still looks kind of mostly filtered, deduplicating, splitting. That looks like data flow. Like this is what happens to my message. Does this adequately reflect how this actually happens? And perhaps I still need to work on my language a little bit, but the from here is the hint that you're pulling something from. Maybe I rename this to pull from, because that actually defines the control flow. If you wanted to invert the control flow and say, I'm a passive element that just listens for stuff to come in, I would have to expose this at some endpoint, some ARN or something abstract, some URL to say, hey, I'm sitting here, I'm ready for you to push things in, right? That is the control flow aspect, and I'm expressing that in my code in a Fluent API. I actually have this as working CDK code. If anybody uses CDK, I have this as working TypeScript CDK code as a demo. And if you want to do things like, hey, I need a queue in the middle, right? I need to invert my control flow. That is like a one-line change. Because I have this domain model, I have this language where I say, hey, put a queue or buffer, you choose the words, right? I can insert this here, and I have a programming model that represents my data flow, and then I have vocabulary that can give me the relevant nuances for the control flow. And I feel that, that exposes some necessary complexity, like push versus pull, but it makes it easy because I have types against this. So I have a type system in this which knows whether it's push or pull, and then the operations I can use are, I can basically hit like dot control space, and then I can get the proper operations based on push and pull models. This smells a little bit like Cloud Compiler, right? That's if people are in that space, right? This is essentially exactly what that is. So with that, hopefully you enjoyed like a little bit of a garden walk here through abstractions and cloud and car metaphors. But the summary is really that good abstractions, in fact, do meet the buzzword test, right? So they reduce the cognitive load, but they do that only if you have a new language and a cohesive language, then people can build a strong mental model. And if you overdo that, right, too much of a good thing is a bad thing, you land in the dangerous land of illusions. So now I have only, I think, 2 things to reveal. The one thing is here, I'm a bad artist, but I'm sure people can relate to this. So whenever anybody gives you a platform internally, they make it always look like the left-hand side. We call that the paved road and the golden path. It's this super highway that you can go on. But in reality, often all the money gets invested in the guardrails, and they forgot to actually pave the road. So you can show them this picture. It's in my book. And it says, hey, make sure we're on the left-hand side. And the last thing I need to do is I should reveal the impossible object, the illusion that we had. And look, don't always trust your eyes. This thing is real. It's 3D printed. And at the right angle, it looks like an illusion, but it's actually real architecture. So with that, only 2 last announcements, I think, is, the app, rate the session, and B, I put a few cards out there with QR codes for the book. If you're interested in stuff like platform strategy, you can get a coupon for the ebook. So thanks for your attention, and one question maybe. Do we have time?
So thank you, Gregor. And
okay. Thank you. Oh, well,